Section 4.4, parallel and perpendicular lines. Essential question. How does the slope help you to determine whether lines are parallel, perpendicular, or neither? So when we're looking at parallel and perpendicular lines, you can look at what the graph looks like in order to determine what lines are. But the more accurate way to look at it is to see what their slopes are. So two lines that are parallel run right next to each other but never intersect. Perpendicular lines intersect at a 90-degree angle. Now the thing is with graphing lines, it may look like lines are parallel or it may look like lines are perpendicular, but it's very difficult to tell exactly if they are parallel or perpendicular. So the more accurate way to determine that is to look at the slopes of the equations instead. So the slopes of parallel lines always stay the same. So both lines have the exact same slope, meaning that you're always rising and running the same amount each time. Perpendicular slopes flip and change. So what I mean by flip and change is if you have a slope of 1/4, if you flip it around, you'd have 4/1, and changing means you change the sign. So since 1/4 was positive, 4/1 would be negative. So two lines, one with a slope of 1/4 and one with a slope of -4 or -4/1, those would be perpendicular. So parallel slopes stay the same, perpendicular flip and change. Alright, so first we're going to fill in a grid, just thinking about slopes of lines. So if a line has a slope of 5, a line parallel to it is also going to have a slope of 5. If a line has a slope of -3, a line parallel to it will also have a slope of -3. If a line has a slope of 1/2, the parallel line will have a slope of 1/2. So I'm going to continue down my chart, repeating my original slope because I know my parallel slope will be exactly the same. Now when I go over to my perpendicular slope, so I'm going to write same here. My perpendicular slope, I have to flip and change every single one of these numbers. So 5 is the same as 5/1. So if I flip it, I get 1/5. If I change my sign, my original was positive, so my new slope is negative. So -1/5 is the flip and change of 5. So now if I have -3 or -3/1, if I flip it, I'd have 1/3, and my original is negative, so my new slope has to be positive. 1/2, if I flip it, I'd have 2/1. My original is positive, so my new slope has to be -2/1, or you can just write -2. -2/3, flip it, so it's 3/2, and make it positive. 1, well 1 is 1/1 as a fraction, so if I flip it, it's still 1/1, but I have to change my sign to negative. So -1/1 or -1. 4/7 flipped and changed would be -4/7, and -8 flipped and changed would be +1/8. Alright, let's get into the first example. Determine whether the lines are parallel, perpendicular, or neither. So, we have the equations y equals -3x plus 1 and y equals 1/3 x minus 2. Now, I need to look at the slopes in order to determine whether or not these lines are parallel, perpendicular, or neither. So, the slope in this first equation is -3. The slope in my second equation is 1/3. So I need to ask myself, are these slopes the same? Well, no, they're not. So they're not parallel. Are these slopes flipped and changed? Well, let's see. Let's take one of our slopes. So if I take the slope of -3 and I flip and change it, I get positive 1/3. So, is my second slope 1/3? Yes, it is. So it's flipped and changed. So that means my answer is perpendicular. So if I graphed those two lines, they would end up being perpendicular because the slopes are flipped and changed. All right, second one. So this one, the first equation is a little bit different than what we saw on the last slide because it is in standard form, not slope-intercept form. So when we're comparing the slopes, we have to have our equations in slope-intercept form because 3, 4, and 12, none of those are the slope. Standard form does not give you the slope. So we need to get this equation into slope-intercept form first. So that means I need to get y all alone. So let's subtract 3x on both sides. Bring down the 4y. And then keep the -3x and the 12 separate because they are not like terms. Then I need to divide everything by 4 to get y alone. So y equals -3/4. 12 divided by 4 is 3. So now let's write down what our slope is. So our slope of this first line is -3/4. The slope of our second line is 2. So now we have to ask ourselves, are these slopes the same? Well, no. 2 and -3/4 are not the same. Are they flipped and changed? Well, let's take -3/4 for example. -3/4, if you flip and change it, would be +4/3. Well, my second slope is 2, not +4/3. So the answer to that question is also no. So if they're not parallel and they're not perpendicular, my answer is neither. So if they're not the same and they're not flipped and changed, it is neither. So -3 and +2 would be neither. All right, and the last one. Determine if they're parallel, perpendicular, or neither. Both of these are not in slope-intercept form, so we need to get them into slope-intercept form first. So keep in mind, you can never decide if lines are parallel, perpendicular, or neither if you don't know the slope. And you only know the slope if it's in slope-intercept form. So I subtracted 4x on both sides, and then I'm going to divide every single number by 6. So -4/6 can be simplified to -2/3. So now we have this in slope-intercept form. My slope is -2/3. Now let's look at the slope in our second equation. Now this one just has 3y on the left side, so the only thing I have to do in this one is divide. I don't have 2 steps, I just have the 1 step, just the dividing. So my slope in this second equation is -2/3. So if I ask myself my questions, are my slopes the same? Yes, they are. So that means my lines are parallel. Same slope means that the lines are parallel. All right, a click and drag. So parallel, we need to find all the equations that have the same slope. So in this first set, both of these equations have a slope of 3. So they are parallel. Let's see if there's any others where the slopes are the same. This one, both of the slopes are 6, so those are also the same. Let's see if we have any that are flipped and changed. Well, if I take -4 and flip and change it, I would get 1/4. So -4 and 1/4 are flipped and changed. Now let's look at this 1/5 and 5. These ones are flipped, but they're both positive. One of them would have to be negative in order for it to be perpendicular. So that one is neither. And this one with 2 and -2, they're changed, but they're not flipped. So that one is also neither. So remember, for a perpendicular, it has to be flipped and changed. It can't be just flipped or just changed. Summary.